So for number 1, you would take a derivative to get velocity. You would graph them both, see what they look like, look for their intersections, and there's one, and then there's another one over there that is kind of hidden. So be careful, make sure you understand what you're looking at. Okay, 1b, average velocity versus instantaneous velocity. So average velocity makes me think of like algebra rate of change. So just good old slope. So change in s over change in t. Or I guess we're in x's here. So x at pi over 2 minus x at 0 over pi over 2 minus 0. That will be how far it moved, its displacement over change in time. Negative cosine pi over 2. Oh, careful. Minus negative cosine 0 all over pi over 2. And here's the good news. That is a safe stop. Cosine pi over 2 is calculator ready. It's a pre-cal topic. That's an acceptable answer. Now, on a multiple choice, there's no way they leave it like that, but you are allowed to. That is a safe stop. Perfectly fine answer. Cosine pi over.
If you're given a calculator, you can still save stuff. Okay.
Yep. So anything after that is a safe stop as well. So I guess 2 over pi would be the best multiple choice answer, but I wouldn't take it all the way there. All right, 1c, find the instantaneous velocity. Average versus instantaneous. Instantaneous makes me think calculus rate of change, calculus slope. So instead of delta x over delta t, like that's a finite difference, we want dx dt, a small difference, so a derivative. So I don't know that we've looked at those that closely before. Change in x over change in time versus dx dt. This is algebra, this is calculus. And we already have this equation up here. So v1 at pi over 2 is the sine of pi over 2, which is a safe stop, but that is equal to 1. So average velocity versus instantaneous velocity. Average rate of change versus instantaneous rate of change. Algebra versus calculus. Number 2. Kind of work this one together. If f of x equals 1/3 c minus x all cubed, and c is a positive constant, when is f of x increasing? Okay, that function looks weird with a c in it. But let's worry about what it's asking first, and then we'll figure out what this c thing is. If f is increasing, what would that mean to a calculus person? Okay, you said positive slope. What would have a positive slope? F has a positive slope. Okay. What else could it mean? That's true. That's not wrong. Positive velocity if this is a motion type thing. But there's a word I'm looking for that I haven't heard yet. A positive derivative. If f has a positive slope, then f prime is positive. So if we can find the derivative of that thing, then we can figure out when f is increasing or decreasing. Okay, c is a positive constant, so it's weird to see it in there, but let's just think that it's 2 or 3 or 7 or 12. I can't plug one of those in, but when I'm looking at it, I don't want to be thrown off. It's not a variable, it's just some number. So let's take the derivative. So product rule, 1/3 times 3 times c minus x squared. And quite a few people are going to stop there, and they will be wrong. Chain rule. What do I need to include in my answer to account for the chain rule? Times -1 by the chain rule. Because the derivative of c minus x would be -1. So just kind of rewrite this a little bit to make it look nicer. Negative c minus x squared. So I want to know where that is positive and negative. So I'd like to know where it's 0 first, because then I can put that on a number line and check my intervals. So what would make negative c minus x squared be 0? What value of x? C. It's a little bit weird that there's a c in there, but if x was c, then the first derivative is 0. So I need to find f prime of something left of c and f prime of something more than c. I think less than c isn't too bad, because it tells me that c is a positive constant. So if c is a positive constant, what's a nice number left of a positive constant? 0. So I'm going to plug in 0 to f prime. So negative c minus 0 squared, again with the c business. But all I care about is plus and minus, so square anything, it's positive, put the negative on there. So that means f prime is negative. Left of c. Okay, that's helpful, but it doesn't answer the question exactly yet. If f prime is negative, what does that tell me about f? It tells me f is decreasing. I'm out of space, but f is negative, therefore f is decreasing. All right. Can I use the alternating rule? It just changes signs every time. Do you know when you can use the alternating rule and when you can't?
You can use the alternating rule.
If there's an odd exponent, if there's not a double root, we can alternate. Is there a double root on this one? Yes. So I can't alternate. In fact, I can use the fact that I can't alternate to say that this side is going to be, should be negative as well, because it's not going to alternate. If you don't like that, then you got to pick a number bigger than c. What's a number bigger than c? It's like, I don't know what c is. So how do you pick a number bigger than c if you don't know what c is? What's that? C plus 1 would work. Anything else? I like c plus 1. That'd be bigger than c. Since c is positive, you could use 2c, or 3c, or 4c, or 5c. Be careful though, that would only work because we know c is positive. C plus 1 definitely would work. So if I plug in c plus 1 for x, well, it kind of doesn't matter, because whatever's in there gets squared and then we stick a negative on it, so it's negative. And if f prime is negative, that means f is decreasing. So f is decreasing left of c and decreasing right of c. So where is f increasing? What's the answer to my question? If it's decreasing over here and it's decreasing over here, yeah, then it's never increasing. right, so a couple things covered in that one. Increasing goes with F increasing, decreasing goes with F prime being positive or negative. Dealing with the C, that's a little bit tricky, and then the chain rule reminder was in there as well. So lots of things covered in number 2. Number 3. Graph of velocity is shown below. Should label that. Graph of velocity is shown below. So you can do a little sketch. When is the particle farthest to the right? And we could even say things like f prime of 1 equals 0, f prime of 3 equals 0, meaning that's where the maxes and mins are of the graph of velocity. So the particle is farthest to the right.
It's asking when is the graph highest.
It's not asking when the graph is highest. It's asking, if it
right,
wanted to know when the
too.
graph was highest, it would say when is velocity the greatest. That would be at t equals 1. And I'm sure that would be one of the
It
answer
moves
choices.
right when velocity is positive.
It's gotta be 2.
It's at
Got it.
That's an easy multiple choice set to write. Why do you say 2? You're right, it is 2. Where, careful, that was almost a good answer. You can't say it, where what goes positive to negative.
Line.
The line.
The velocity.
The velocity changes positive to negative. I don't know why I use a symbol for plus and then a neg for negative, whatever. So if it changes from positive to negative, that means it was traveling to the right, and then over here at t equals 2, it turns around, and so it's the farthest at t equals 2. I said 2, and I wrote 0 for some reason. So it gave me some information that I didn't really need. It reaches a maximum velocity at t equals 1. That's when it's moving to the right fastest, but it's still going to the right between 1 and 2. Where is the particle, adding this on, forgot about this. Where is the particle, let's say, slowing down? Where is the particle slowing down? Well, it's going to be an interval, not just a point. So, justify first. What does it mean to be slowing down?
acceleration and velocity have to.
Yeah, not necessarily slope negative. That would mean acceleration is negative. But slowing down means A and V have different signs. So I think a number line, maybe you could do it without a number line on this one, but I'm going to do a velocity number line and an acceleration number line. So the velocity one's easy, because all I care about is positives and negatives. From 0 to 2, velocity is positive. From 2 to 4, velocity is negative. Again, that's why it reaches its farthest point at time equals 2. That's where it turns around. What about acceleration? What's it doing? What's the first interval of acceleration I should... What's the acceleration right in here? Positive or negative? Acceleration is the slope of velocity. So it's positive until 1, and then negative until 3, yep, because the slope of velocity is negative, and then positive from 3 to 4. So it's slowing down. They have different signs from 1 to 2 and 3 to 4. Okay. Again, all test-inspired stuff right there. So you will see that again tomorrow or Thursday.